The sun. This constant companion delivers the energy that powers life on Earth. But for over 4.5 billion years of Earth history, the amount of energy the Earth has received from the sun has varied, with major consequences for the climate and for living things. Even the relatively stable climate humanity has enjoyed since the end of the last ice age is regularly affected by small changes in the amount of solar radiation reaching the Earth's surface. These small variations are caused by long-term cycles affecting the Earth's orbit around the sun, changes in cloud cover, and other fluctuations here on Earth. They can have major impacts on our lives. The 1991 volcanic eruption of Mount Pinatubo, for example, spewed huge clouds of sulfur aerosols into the air. This reduced the sun's irradiance by up to 5% for around 10 months, which cooled the Earth by some 0.5 degrees Celsius for several years. This is why measuring the sunlight hitting the Earth is so important. It is critical to our understanding of the weather and climate system. Scientists need radiation measurements in order to study climate variability and change and to forecast the weather.
Solar radiation is really what gives us the climate that we have. The warm tropics, the cold poles, it's the amount of solar energy that hits and how that's distributed around the planet, how much gets absorbed into the ocean, how much hits the land surface.
Radiation measurements are also essential for decision makers in the solar energy industry. To calculate how much electricity a proposed solar energy installation will produce, they need to know how much sunlight will be available on sunny days and cloudy days, or on short winter days versus long summer days.
High-quality radiation measurements are essential for scaling up solar power. They help improve the accuracy of radiation estimates based on satellite data. For example, the Global Solar Atlas. These estimates are used by decision makers and commercial investors to identify suitable locations for solar power plants.
Measuring sunlight, however, is not as easy as it may sound. We need long-term measurements that are comparable from place to place, from time to time, and from instrument to instrument. This requires a special effort to finally calibrate thousands of ground-based instruments all around the world. The PMOD Institute in Davos, Switzerland, has been studying how to measure sunlight for over 100 years. Since 1959, it has organized a meeting every 5 years, bringing together scientists from around the world to simultaneously calibrate their instruments. In 1971, the World Meteorological Organization invited the PMOD to serve as the World Radiation Center. The center maintains the primary standard for measuring the sun's irradiance, the so-called World Radiometric Reference. This ensures that these highly sensitive instruments, known as pyrheliometers, are accurate and their data are comparable. Accuracy is particularly important for the solar energy industry, which needs to know the absolute amount of sunlight that is available, while comparability is critical for climate science, which tracks trends and changes over time. Wolfgang Finsterle is responsible for solar radiometry at the WMO World Radiation Center. He maintains the World Standard Group, comprising the 6 measuring instruments against which instruments around the world are compared.
Well, our role is to make sure that everybody uses the same accurate scale for measuring solar irradiance, to make those measurements comparable to each other and to measurements that have been taken in the past and will be taken in the future.
Without international collaboration on carrying out this rigorous behind-the-scenes work, we would have a much weaker understanding of the climate system.
Without the IPC, countries can't compare their radiation data. We would not be able to look at effective climate records throughout the globe. So this is a very vital, important part of the role of WMO.
The World Radiation Center will organize the next global intercomparison meeting in 2020, and will continue its work on assuring the quality of solar radiation measurements far into the future.